Hello everyone. In this lecture, I will discuss the gate previous problem on one price break model. Let's see the problem. Annual demand is 2500 units per year. Ordering cost is 100 rupees per order. Inventory holding rate is 25% of unit price. The optimum order quantity is, and also given the data is, order quantity is the less than 500, unit price is 10 rupees. If the order quantity is greater than or equal to 500, unit price is 9 rupees. Then have to determine the optimum order quantity. So that is options are given. Option A is the 447, option B is the 471, option C is the 500, option D is greater than or equal to the 600. So let's see the solution. First write down the given data. So here one price break model. Here break price quantity is the 500. So B1 is the 500. Annual demand, that is the D, is 2500 units per year. Ordering cost, that is the C0, equal to 100 rupees per order. Inventory holding rate 25% of unit price. So small r equal to the 25%, that is the 0.25. And also it is given the unit price cost, that is the C1 equal to the 10 rupees and the C2 equal to the 9 rupees. So let's solve the problem by the step 1. So step 1 is the consider the lowest price. Here lowest price is the 9 rupees and determine the Q2 star by using the EOQ formula, that is Q2 star equal to the root of 2D C0 by C2 into small r. So first I have to determine the Q2 star. So here D is the 2500, C0 is the 100 and the C2. So lowest price, that is the 9 rupees, and small r it is given the 0.25. Then I have to substitute all the values in the Q2 star formula. We will get the Q2 star is the 471.4 units. And observe that one, the Q2 star is greater than or equal to B1 or less than or equal to B1. Here Q2 star is the less than the B1, that is the Q2 star is the 471 and the B1 is the 500. So it is the 471.4 is less than the 500. So Q2 star is less than the B1. So then we have to go for the step 2. So step 2 is the if Q2 star is less than B1, we cannot in a place an order at the reduced price C2. So therefore, in order to maintain the optimum order quantity, we need only to compare the total inventory cost for the Q1 star and the B1 quantity. So here you have to determine the total inventory cost at the Q1 star with price rate of the C1. So this is the formulas for the total inventory cost at the Q1 star quantity and the B1 quantity. Here we have to determine the total inventory cost at the C1 price, but total inventory cost for the B1 quantity we have to determine at the C2 price. So this is the TC, total inventory cost at the Q1 formula is the DC1. So this is the purchasing cost plus D by Q1 star into C0. This is the ordering cost plus 1 by 2 Q1 star or C1. So this is the carrying cost. Similarly, total inventory cost at the B1 quantity, that is the DC2 plus D by B1 into C0 plus 1 by 2 B1 into RC2. So before that one, I have to calculate the Q1 star. So here, considering the C1 equal to the 10 rupees, then I have to find out the optimum order quantity, that is the Q1 star. So previously we determined the Q2 star at the C2 cost. Here we have to determine the Q1 star at the C1 cost. So we know the formula 2D C0 by R into C1. Here C1 equal to 10 and D is the 2500 and the C0 equal to the 100. Then substitute, we will get the Q1 star equal to the 447.21. And we know the B1 quantity is the, so here 500 units. sorry, here 500 units, B1 is the 500 units. So next we have to see the, so next we have to calculate the total inventory cost at the Q1 star quantity as well as the total inventory cost at the B1 quantity. So Q1 star quantity is the 447.21. Then we know the D value we know, C1 value we know, Q1 star also we know, C0 we know, and R also we know. Substitute the all values, we will get the total inventory cost at the Q1 star, that is the 447.21. Then D equal to the 2500 into C1, that is the 10, plus D, that is the 2500 divided by Q1 447.21, C0 ordering cost, that is the 100, plus 1 by 2 into Q1 star, that is the 447.2, into small r is the 0.25, C1. So price for the, so C1 for, so C1 equal to 10. Then I have to substitute all values in the TC, total inventory cost at the Q1 star. We will get the value as the 26,118 rupees. Similarly, you have to calculate the total inventory cost at the B1 quantity. So for the 500 quantity, here D we know, that is the 2500, C2 value, that is we know the 9 rupees. Similarly, we know the B1 value, that is the 500, C0 value we know, that is 100, and R value we know that one the 0.25, and C2 is the 9. Substitute the all the values in the TCB1 equation. We will get the total inventory cost at the, for the 500 units, we will get the 23,562.5. Then we have to compare the TCQ1 star as well as the TCB1. Here, if the total inventory cost at the Q1 star quantity is greater than the total inventory cost of the B1, then our optimal quantity is the B1 quantity. Otherwise, optimal quantity is the Q1 star quantity. Then I have to compare here total inventory cost of the Q1 star, that is the 26,118, and total inventory cost at the B1 quantity, that is the 23,562.5. So the relation is the TCQ1 star is greater than the TCB1. So 26,118 is greater than the, so 23,562. So then optimal order quantity will become the B1. Here B1 quantity is the 500. So option C is the correct. So thank you.